Hello everyone, welcome to my channel. I am Nilesh. In this video, I am going to explain what is entropy and some of its easiest definitions and some of its easiest examples and necessary of entropy, finally expression for entropy. Without wasting your time, let's begin. I hope you all familiar with laws of thermodynamics. Let's recall them. The first law of thermodynamics states that energy can neither be created nor be destroyed. It speaks about the quantity of energy you are adding to the system. Now, second law of thermodynamics states that the amount of energy you are adding to the system is ultimately transformed into less useful form of energy. So, it speaks about the quality of energy you are adding to the system, as energy disperses and ultimately degrades into waste. In other words, when organized energy such as a high quality of energy or high usable energy or highly concentrated energy degrades into disorganized energy. Here, disorganized energy is nothing but low usable energy or low quality of energy. For example, when water flows over a waterfalls and it loses its potential for useful work. See this image. When water falls on a water mills and there will be spin or rotation. So that denotes there will be work done. Now we can take another simple example. Suppose any gasoline engine or petrol or diesel engine where organized energy degrades as energy burns in the engine. So here the useful form of energy degrades or transforms into non-useful form of energy, and it is the unavailable energy for doing the same work again, that is driving another car, which means that when you start the car there will be exhaust or there will be carbon dioxide. You have to collect that carbon dioxide and use it as fuel for other cars, and it is highly impossible. So when heat is released or dispersed into the environment as a thermal energy, it's ultimately become less useful form of energy. Hence, the quality of energy lowered with each transformation, as energy of organized form tends to degrade into disorganized form. So, from all these broader perspective, we can state second law of thermodynamics in another way. That is, in a natural process, the high quality of energy tends to transform into low quality of energy. That is, order tends towards disorder. We can get this statement by simple example. That is, when you push a box which contain heavy materials across a rough surface, then all your work goes into heating the floor as well as box. Why it occurs? See this image. Because work against friction produces heat, and that heat can't do any work on that box. So here the organized energy transforms into disorganized energy. Suppose we can take another example. When ice in refrigerator, see this image, then all molecules stick together. When ice at room temperature, then ice starts melting, then approaching disorder state. So the all molecules of ice or all molecules of water dispersed randomly due to surrounding heat. Now consider a system consisting some coins on a table and all heads up. See this image. Then accidentally somebody disturbs the table or disturbs the coins. Then all coins topple to the floor, and certainly not landing all heads up. Notice here order becomes disorder. When molecules of the gas moving in a harmony, which make up an orderly state and also an unlikely state. In other hand, when molecules of the gas moving in a random direction with broader range of speed, which make up a disorderly state and also it is a likely state. We can get this by some simple example. Suppose when you spray the perfume or when you open the oven door which contain some hot cookies, then molecules of cookies or the molecules of perfume escape into the room and achieve the more disorderly state. So here the relative order becomes disorder. And one thing you have to remember, you would not accept the reverse the procedure by itself. That is, you would not accept the molecules of the perfume or cookies molecules to spontaneously orderly themselves back into the perfume bottle or tray of oven and thereby return to the more order state. So the process in which disorder returns to order without the help of any external work which doesn't occur in nature. Interestingly, time is given a direction via this thermodynamic rule. That is, time's arrow always points from order to disorder. See these images.